Hi, everyone. I'm really excited to be here because this session is one I wish I had myself a few years back. I have a background in Cisco IT network operations, and I got into automation almost 10 years ago. And when I was getting automation, it was just Ansible and NetMiko, some really basic scripting options. And Nornir wasn't even on the horizon at all. So this session is what I wish I had when I first got started, and before it even existed. Nornir is going to give you options that you didn't have available to you in automation based on other platforms. And we're going to walk through a lot of demos today that are going to go through how to get started, how to connect to network devices, and how it compares to other solutions. And just for your information, you can use the Cisco Live app to connect to the session and be able to access the WebEx room. I've posted the GitHub repo on there, so you can access all the code that I'm walking through today. So on the left, I have a visualization of Ansible. How many of you have heard of Red Hat Ansible? Played around with it? Yeah, it's pretty popular, and I still love to use it today. But it can also come with some limitations, because you're working with YAML, you're working with certain levels of abstraction. On the right, I'm calling it Pythonic control with Nornir. So Nornir is a Python-based network automation framework that allows you to have a lot more fine-grained control in connecting to your network devices. Well, what is Nornir? Nornir is a pluggable, multi-threaded automation framework with inventory management. It basically allows you to connect to the devices. As you've worked with Ansible, you have your inventory file, you have your modules, you have your playbook. Nornir gives you all of those constructs minus the modules. It allows you to plug in your own Python-based automation to talk to the network devices however you want. They have some built-in ones that I'll demonstrate today, both NetMiko and Napalm. But really, the sky's the limit in terms of what you're able to do. And you can see on the architecture here, I pulled from their documentation. You can talk over SSH, netconf, restconf, really whatever you want. And I know oftentimes in enterprise environments, you're constrained based on the tools, because you might have your own internal systems that you want to talk to, and Python is the easiest way to do that. So I would highly suggest considering Nornir for those situations, not just because it's all Python-based and it gives you more flexibility, but it gives you the ability to then connect to your different internal systems. I also wanted to just start off the session with a brief comparison between Nornir and Ansible. For those of you who are familiar with Ansible, it seemed like most of you were. Ansible uses the concept of a playbook to define the series of tasks that you're going to work with. Nornir, you're simply making a Python script. Of course, you could build it out into full-blown Python frameworks, but Nornir itself, at its very core, doesn't require that. Instead of using Ansible modules, you're using basically your own Python functions that use the Nornir task.run. You're running Nornir tasks that we'll see in a minute in some demos that will leverage either NetMiko, Napalm, or whatever other Python functions you want to be working with. And I'd say one of the things people often run into, myself included, when you're maybe running into the limitations of Ansible is conditional logic. You're trying to build more complex scenarios. Okay, if this particular situation happens, we want to have nested tree logic, and it gets really complicated really quickly. So Ansible can be very helpful for teams that want to have a simple workflow that you're sharing it easily with another team, and maybe you're getting started network automation, or you already have Ansible used for compute or cloud or other situations. Nornir gives you a lot more flexibility, because basically whatever you're working with in Python, the sky's the limit. And of course, they both use Gen 2, and I'll be showing an example in a minute exactly what that looks like. So one other thing I wanted to mention as we're getting started here and kind of setting the stage of why should you consider using Nornir. It's a free and open source library. You don't have to pay for it. It's maintained by people who volunteer their time and care about network automation. And one of those people who has helped maintain it created a blog and showed a side-by-side comparison in terms of the speed of Nornir. And this isn't even talking to network devices. And obviously, it's still faster than doing it manually, whether you're using Ansible and NetMiko versus using it manually. But for Nornir, the real bottleneck came when you're serializing between in the internal mechanics of Ansible into JSON back and forth. When you're talking about tens, hundreds, thousands, or 10,000 devices, they did an actual test for the series of numbers of devices. You can see on the left, the Nornir is so small on the graph you can't even see it. because it doesn't scale at the same rate that Ansible does. And I have put the link to the test that was done here from Network Lore, so you can reference the slides later and actually look in the data. But Nornir is actually significantly faster than Ansible when you're talking about scale. So not only is it give you more flexibility, but you actually get a lot more performance improvements because Nornir has built-in multi-threading. Because I know for a lot of us, if you started maybe doing Python scripting with NetMiko, like, okay, I want to do it more than just a couple of devices, suddenly you're having to build your own threading framework and looking at documentation, and Nornir gives you that all built in. And Ansible does have its own threading mechanisms, but as you can see when they ran the tests, Nornir gives you a lot more performance when you're actually talking to network devices because you don't have the overhead. Ansible has to handle a lot of things behind the scene that Nornir doesn't have to worry about. So in order for you to first get started in Nornir, like, okay, what do I first have to set up? The first thing is your Nornir config file. So your Nornir config file is going to tell Nornir how are you going to be actually talking to your devices. What's your inventory file? Because by default, in all the examples today, I'm going to be showing just a YAML static file of setting up maybe a basic demo instance, but Nornir has plugins talking to Netbox, talking to Notabot, and you can also build your own custom Python code that connects to really any source of truth or any other data store as long as you're giving the right data set into the application. So here we have an example of a config file. I'm using the basic YAML simple inventory setup. And you can define how many numbers of workers you want to be working in your multi-thread scenario. You can optionally also have it do serialized, because sometimes for those of you who have worked in a threading scenario, it can be difficult to follow your logs sometimes because things are working asynchronously. So if you want to be able to troubleshoot a bit easier, you might want to switch to a serial option for your runner. But I'd say generally you're more worried about performance when you're talking about network automation. So the threaded is what most people are going to be using. So the first thing you do is you set up your config file, and then you're saying exactly what type of network inventory I want to be talking to, and I'll be walking through those inventory files here in a second. So the Nornir inventory, actually they have a plugin that allows you to even load in your Ansible inventory if you want as well. But by default, you have, this is the Nornir inventory schema. I put that up there just because when I was first playing around with it, I was like, what are the available options? What are the different keys that I would be wanting to plug in values? You don't need to put in all of these options, but you're going to need to want at least know what the IP address is, what your credentials are, and probably have that plugged in with some type of Vault, Terraform Vault, or some other type of secure storage situation. So on the left-hand side, I have the static inventory files. We have a defaults file, a groups.yaml, and a host.yaml. So the default is your baseline. So you say, for all my devices, this is the information I want there. And for each of these three tiers of inheritance, so we have defaults, groups would be either platform-specific, maybe site-specific, say all of my devices in my San Jose location have these particular variables defined. And then from there, if any of those are not defined on the host level, you can also define specific values. And if you want to access your different values from your inventory, they're all merged at runtime. And the host level supersedes the ones from the higher levels. So you can see some examples here, and I'll have examples in the code as well. But basically, your tasks just use simple dictionary lookup notation for the different values that you're going to be working with. In my examples, I simply plugged in my credentials at the defaults level because I'm using a demo. I don't care about having my credentials in plain text. And I figured for other people who are getting started, maybe want to get it up and running quickly, that gives them a simple place to update with their own credentials for the lab devices. And then on my groups level, I just simply define my platform information. So I'm using both iOS and Nexus devices in this demo using a DevNet sandbox that you all can also reserve on your own and follow along later. And then on the per device level, I'm defining the IP address, which groups it's defined to, and then any additional data. So you can see we have this data key on the schema, and I have on the left-hand side the data that basically you can define any type of YAML-based key value pair, lists, dictionaries, all those kinds of typical information you'd see in YAML that you can either use in your code or in your Jinja templates. So and that same data field you could also define then in your platform groups level or even at your defaults level. But for my examples, I'm just defining them all at the host level because I'm trying to keep it relatively simple. So now that you have your config set up and it knows which inventory files you want to be working with, where they're located, and then you've set up your inventory files for your defaults, your groups, and your per host YAML files for our example, how do you actually run a task? So running a task basically involves instantiating the Nornir object using the init Nornir after you've imported it, of course. And this is the sample code snippet that I'll be executing for our first demo, where after you have imported the init Nornir, you need to tell it which config file you're working with. And so in my case, I just have a config YAML file in the current working directory, so I'm pointing to that. And that config file then tells Nornir the other inventory files I'm working with. And then after I have my Nornir object, I can then run the method of nornir.run, in this case, nr.run, but it's hard to say nr, so I'm just going to say Nornir. And you provide a parameter of the functions that you want it to run. And behind the scenes, that's going to then spin up the threads that will then execute across the devices based on however many devices you have from that config YAML file from your inventory. So in this first example, I'm basically going to call this other function. So you can see we have a greet host function that we have our Python function defined here as greet host, and we're going to access variables from our inventory file and then print them to the screen. Just kind of showing a basic example of how they work together. Okay. So we have our Python code that we saw earlier here. We're importing Nornir. We're doing Nornir run on our greet host method. And we have our task as an input that we're passing in. So then we can reference the task to say task.host for any of the hosts. So in this case, we have both a Nexus and iOS device. I'll take a look at my defaults. We can see my super not secure credentials, also defining our port. We have my two groups. So these are all going to be merged in at runtime of iOS and Nexus, defining my platforms for things like NetMiko or Napalm. And then my per host YAML file. So I have an iOS device with my IP address defined, the groups that it's a part of, and additional data that we'll be using in some later examples. Then the same thing with Nexus. So for this first script, we're simply going to load in that config file and print out the values of the name, the platform, and the host name. And it runs very quickly. And you can also notice because it was running in a multi-thread environment, the printing actually didn't run out sequentially. So if I run it again, it might actually look a little bit better. Nornir actually, for this reason, includes its own print function that kind of prints things in an Ansible-like way, which I'll show in a later example. But that doesn't stop you from actually printing it in just the regular Python way. And you can see an example here of why you might want to let Nornir handle some of the printing. So we were basically just here, not even talking to the network devices, just accessing data from the inventory to show how you get your Nornir set up initially. So after you run that task, so you've done nornir.run, you've plugged in a function, and then that function returns results. Within Nornir, it actually has additional capabilities of what they call a result object. And for me, this was the most confusing part in the whole process of Nornir, because when I was coming from Ansible, I was like, okay, I can plug in my inventory file, I can plug in my device connections and my host names. But for Nornir, it actually returns a Python object that you can then work within that nested object. And I've provided a visualization on the left there where the Nornir object at the top level is called an aggregated result. And then for each device, you have a key that you can look up for that host name. So we have two devices, so we could do two different lookups, one for our iOS device and one for our Nexus device, and then you have the associated results for each of those objects. And if you don't want to worry about all that, you can still just build your own return objects, but this does give you additional features and capabilities for those of you who want to work more Pythonically in the deeper weeds of working with different attributes that they have built in Nornir. We also have a dot result and dot failed and dot exception attributes for these result objects that allow you to extract out the values of either the actual output for the dot result, a true false value if there's any type of failure, and then also it has its own Pythonic exception catching. So if you run and you your code, and then it throws an error. It doesn't actually crash your script. Nornir handles that exception for you, and it'll put back that exception in the dot exception value within that results object. And if you're not comfortable with this part, don't worry about it. I just at least wanted to give people some explanations and a real example of how you might use this. So I'm going to go through this next demo in a second where we're going to be basically taking some information from our network device inventory yet, still not talking to the network device, but just unpacking and printing out our Nornir object. So let's take a look at that example here. So we'll go to our results object. There are also Nornir utils. So I'm importing at the top another function that I mentioned earlier. There's a print result that allows it to have an Ansible-like printing experience that you'll see in a second. And that's in the Nornir utils additional Python package. Moving into the script, we have our initialization of our Nornir object, and we're plugging in our config file, and we're doing nornir.run and getting our result object from there. And the function is going to be formatting a site label, because I think a lot of us, if we're working in an environment that's of any size, you have some certain types of naming conventions. So I tried to pick a simple example of being able to extract values. And for those of you who might have noticed when I showed you the host file, I've actually commented out the site and role keys in one of the devices. So it's going to force a key error for one of my devices, and the other device, when I run it, will run successfully. So this will then show us what it looks like for Nornir to handle a Python error, and then us to be able to extract out those values on the screen. So we're going to have our result object printed out, where we're taking our site and role information and then putting them together in a single string and printing it out to the screen. And one of those is going to throw a Python error. And then we'll take the output of that object and extract out the result, so that's combined site information that we extracted from our inventory file. If there's a failure, true, false, and then if there was an exception, printing that out to the screen. So let's go ahead and see that in action. So I'll go ahead and scroll up. So we can see I ran my Python results object script. And now that we're using the print results utilities built into Nornir, you can see we have the nice red with the task that failed. It all kind of printed sequentially rather than because it was threading, it didn't mess up the order. So that is another benefit. And you'll notice it said it could not format the label because I purposely commented out those inventory data values that it was trying to extract to force that error. So the iOS device had an error, could not format the label. The Nexus device was successfully able to take the two values from the inventory and combine them into a string called DC1 core. And then we can see the unpacking of the result object in this last part here, where we had our error message of could not formatting the label. So that was the result that we were extracting from our result object. It did fail, so we saw that it successfully marked that as a failure. And the key that it failed on was the site key from our inventory file. Versus the second one was completely successful. The result is successfully rendered as DC1 core, and there was no failure and no exceptions caught. So now that we've shown how to work with the result object, get your Nornir up and running, how do you actually start talking to network devices? So for anybody who's done any type of network automation for any amount of time, you're probably familiar with NetMiko. So NetMiko allows you to talk to network devices, and there's a list of built-in plugins that work with Nornir that you don't have to do any additional work to get them set up. And NetMiko is one of those. So for NetMiko, there's a NetMiko send command Nornir Python import you can do. And this is the most simple example I could think of to kind of show how people can connect to their network devices using Nornir, where you create your Nornir object, you plug in your inventory file, and then run basically nornir.run, and we're doing what's called a keyword arg. So the netMiko send command is expecting our command string, and so we're able to just plug that in as an additional parameter within our nornir.run, and then it'll be passed along to our netMiko send command function. And so we don't have to build another function necessarily. I'm just trying to keep this relatively tight and simple to show you how can I actually talk to a network device relatively easily. So let's go ahead and see that one in action. So I'll move to the code. So just like we saw earlier, the same code from the slide where we are importing Nornir, doing Nornir.run against our Nornir object, and using the netmiko send command. And you'll notice that we didn't actually have another function that we're calling. We're just using it as straight from the import and passing in the show version as a keyword argument as an additional parameter that gets passed right into send command. And we'll be printing it to the screen using the Nornir print result helper function. So now let's see that to screen. So Python 3, netmiko show command. So now it's actually connecting to the two devices. So first it's connecting to the iOS device and then to the Nexus device, probably in parallel with its threading. And we have our results. So we can see our first result at the top here. And it took a little bit longer than normally just because we're on the conference Wi-Fi. But we have our netmiko send command, and you can see at the top here, that's the function we were calling. And then we have our iOS device is the name of the host that we're working with, and it's doing the netmiko send command. We have simply printed out the show version to the screen for our iOS device, and then doing the same thing for our Nexus device. So that gives you a simple example of how I can fairly easily talk to my network devices using netmiko. For this next example, I wanted to show kind of simulating a playbook-like structure. Of course, you can just run your tasks one after another in your main script or however you want to format your Python code, but you can actually create Python functions that chain together multiple tasks and then load in data from previous tasks. So at the top, I have an example of a method that I'm running that's running two tasks. One that's going to do a show host name, extract out the string of the host name, and then a second task that will take that hostname value that it stored in a temporary variable, and you can see that in these two functions where we're extracting out, we're doing task.host, and that's not from my inventory file in terms of a variable. I'm just creating a new variable on the fly, and I'm storing those per host variables in there. So I have multiple devices I'm working with, and I'm automatically being able to save that into a new key. And then I reference that in a later function called setLoopbackDescription. You can see there it says description hostname, which is then defined from our task.host.get for our hostname from device, where it's extracting out the string value that we had pulled from a previous example or previous function. So using that methodology, you're then able to have multiple tasks executed in sequence and referencing the data in between the tasks. So let's go ahead and see here. For our task chaining, we're working with both the iOS device and the Nexus device. So we do the get host name, we were able to extract out the host name, and then we can show that we were able to now send netmiko configuration commands using the netmiko config commands library. And one other thing I forgot to mention is we actually did one other thing that I glossed over in the code, and we were actually filtering out the Nexus device. Because sometimes you don't want to run all your commands on all your devices. Maybe you want to have just a subset of devices run with your commands. And the way you do that is when you initialize your Nornir object, you can use the additional filter method and then define the platform or whatever other variables you want to be filtering on. So in this case, it's saying I only want to run these commands on my iOS devices, and I do that with Nornir.filter, and that platform equals iOS is referring back to that group's YAML file that I was working with. So one other example I think is common for network engineers, okay, I can send show commands, I can send configuration commands, I can chain them together in kind of a pseudo playbook-like structure, but how do I actually build configuration to then push the devices? So Nornir has a built-in Jinja 2 templating helper function, and I've defined the data. You can, of course, define the data wherever you want, whether that's in a source of truth or in your own JSON files, but since I have it attached to my inventory file, I can actually just directly reference. You'll see in our code here, we're doing Nornir task.run, we're using the template file helper function, and we're referencing our loopbacks, and that's from our host.yaml. So we'll be just directly extracting out our YAML variables from our per host device data, and then plugging that into a Jinja 2 template. And you can see the example of our Jinja 2 template on the bottom there, just creating some interface loopbacks as a simple example. So let's go ahead and see that one in action, and I'll show you the script here first, you can kind of see it all together. We are importing the netmiko send command to configure the loopbacks. We're using the Nornir Jinja 2 plugin to actually render the template. We have a function that renders and applies the template, loading in our Jinja 2 template. We have defined our loopbacks file. And then we have the loopbacks variable that we're loading in from each device's data variables. And in this case, I'm filtering just for the iOS devices as well, not doing the Nexus. So let's go ahead and see that one in action. Oop. Oh, I don't want emojis. Python. So now we're going to be both rendering the Jinja 2 file and then pushing it to our iOS device because we filtered onto just our iOS devices. And so you can see we were able to render our Jinja 2 template, and then we have printed out to screen the actual configuration commands we were interacting with our network device and creating the new loopback. Whoop. One too fast. So one final example I wanted to show you is like, what if we kind of stitch together Nornir with an outside library? So in this next example, I'm including the CSV library, which is built into the Python standard library, where you can take these JSON objects and then serialize them into a CSV. So another plugin that I haven't shown yet is the Napalm plugin for Nornir, where Napalm allows you to have a standard set of keys to talk to your network devices and parse out your operational data into a JSON object. And once you have that JSON object, then you can use Python to plug that into a CSV file, which you can open in Excel. So you can basically use Nornir to build reports. So you can say, okay, I want to know all the interfaces. I want to know all the ACLs for a particular device. Within Napalm, they have different series of getters that parse different parts of the operational data config using show commands and regular expressions behind the scenes. And so for this final example, we're going to be using that Napalm getter to talk to our network devices, and then we're going to use the Python standard library of CSV to take the values that we got from Nornir and then output it into a CSV file. So let's see that code. So you can see at the top here, we're importing CSV from the standard library, not Nornir at all. We're then importing the Nornir plugin of Napalm Get and the print result to screen. We're creating our Nornir object and filtering down just for the iOS devices. And we're using the napalm.get directly to then get our result object. And once we have that result object, I'm going to open a file handler to create my CSV file. And I have a lot of code here that's basically, I know what the key values are going to be because I've run the script before. So you want to make sure, if you're doing this yourself, have the right key values for the extraction of those data fields, and I'm basically going to then plug it into the CSV file. So we'll extract out the data and then take that data and put it into a file to be formatted. So now let's see that in action. So from an output perspective, we get to see our facts. So it ran really quickly to the device, did a series of show commands, parsed out the information, and gave it to us in a JSON format. Once we had it in the JSON format, we then exported it to a CSV file. And if I go to my CSV file, you can see my device facts.csv, which, looking at VS Code, it's not as impressive. But if we open that up, let's see, open preview. You can imagine if you're doing this for tens, hundreds, tens of thousands of devices, you could create a CSV file, Excel file, because there's Python libraries for Excel, or you could be pushing to your own internal database. And that's really, I feel like, where Nornir comes in strong, is that there's a lot of Python examples out there for different ways you can interact with data, different ways that you can scale out your automation, and Nornir gives you that flexibility. So let's go ahead and go to our closing slide. So I want to make sure, no, not just in terms of the examples I have today, but we also have on Cisco U. So I'm within the learning and certification team. We have a ton of tutorials that cover a variety of topics from automation like I'm doing here. I have a Nornir example up there as well as AI, cloud, networking, security. I highly suggest you check out our Cisco U tutorials. And basically from there, that's my call to action to you, is both to check out the tutorials, go to our GitHub link. I put the GitHub link here on the slides. If you register to the session and go into the WebEx space, I have the link in there as well. But Nornir is your workbench. It's where you're able to then build whatever you need for your automation. And it's been out now for about, I think, 5 years or so. So it's a well-supported open source library for you to be able to then interact with your network devices programmatically and scale. Thank you.